Alright, welcome back. In this video we're going to talk about how we determine whether relations are functions based on tables and mapping diagrams. We'll start with tables. To determine if a relation written in table form is a function, we're going to use the same technique we did when it was written in set form. If any of the inputs are paired with more than one different output, then it's not a function, otherwise it is. So we look at the left-hand column of our table, and we're looking for an x value that's paired with more than one y value. If we have one of those, it's not a function, otherwise it is. We see in this one we've got all different x values, therefore this is a function. All right. Then we'll look at example B here. We look again at the x values. And when we do that, we see that we have this x value of -2 that repeats, and it's paired with two different y values. That tells us that this is not a function. All right, then we'll look at example C here. Well, gee, all the x values are the same. So we have an x value, namely 2, that's paired with multiple different y values. That makes this not a function. And then in part D, we look at the x values, and they're all different, so we don't have any x value that's paired with more than one different y value. So this is a function. And again, it doesn't matter here that all the y values are the same. It has absolutely no bearing on whether it's a function or not. We're only looking for x values that are paired with multiple y values. Okay, so that's how we find whether or not a table represents a function. Next, we're going to look at mapping diagrams. And mapping diagrams are really, when we see a mapping diagram, it's really easy to tell from a mapping diagram whether or not a relation is a function. Let's kind of review quick here how we create a mapping diagram. What we're going to do is we're going to create two ovals, one for the inputs and one for the outputs, the x's and y's. And we're going to take all of the x values that appear in the set, and we're going to write them in this oval vertically. Now, when we do this, a couple of things you want to keep in mind. It is best for us to do it in order from smallest to biggest. Also, when we do this, in order for the mapping diagram to really work and be beneficial for us, if a value appears more than once, we are only going to write it once in the mapping diagram. So I look at the x values. I've got -2, -4, 3, and then another 3. So I'm only going to write one 3 since we have duplicate 3's in there. And so I'm going to write them from smallest to biggest. -4 is the smallest, then -2, then 3. I'm going to do the same thing with the y values. We've got 5, 1, we've got another 5, we've got another 1. So I need to write them in order. I only need to write 1, 1 since we have duplicates, and I only need to write 1, 5 since we've got duplicates. And then what the mapping diagram does is it shows us how the numbers are paired in the set. So if a number appears in an ordered pair here, if we have an ordered pair, we're going to draw an arrow from the x coordinate in that ordered pair to the y coordinate in that ordered pair. So for the ordered pair -2, 5, we're going to draw an arrow from -2 to 5. That shows us that the ordered pair -2, 5 is in the set. We're going to do that same thing for all the ordered pairs. We've got -4, 1, so we draw an arrow to pair the -4 and the 1. We've got 3, 5, so we draw an arrow from 3 to 5. And we've got 3, 1, so we draw an arrow from 3 to 1. And that's how we create a mapping diagram. Now before we go on to the last slide, in the last slide we're going to decide if mapping diagrams represent functions or not. The real easy way to tell this from a mapping diagram is look at the values over here on the left. in the group of x's. Are there any numbers that have more than one arrow going away from them? In this case, 3 does. And so I can tell from that, if there are any numbers that have multiple arrows going away from them, it is not a function. Otherwise it is. So since we have one number that has multiple arrows going away from it, this would not be a function. All right, so let's look at a few mapping diagrams to determine whether they represent functions or not. And we look at A, and when we look at A, we look at each of the numbers in the left-hand column of the mapping diagram, and we notice that all of them have only one arrow going away from them. That means that this is a function. And then we look at example B, and we see that the number 4 has 2 arrows going away from it. That tells me that this is not a function. And then I look at C. Each of the 3 numbers only has 1 arrow going away from it. It doesn't matter that they're all pointing to the same number in the y, in the values of y's. The only way it's not a function is if one of these numbers in the x oval has more than 1 arrow moving away from it. So this is a function. And then in this last one, part D, we only have the number 6. It's got multiple arrows going away from it, so that tells us that this is not a function. And that is how I determine from tables and mapping diagrams whether or not a relation is a function. That's the end of this video. See you next time.